In this lesson, we will review the anatomy of a stationary anode X-ray tube. Together, we will discover the parts of the X-ray tube, their function, and the materials that make up these parts. The X-ray tube we will cover in this presentation was developed by Dr. William Coolidge in 1913 and is called the Coolidge hot cathode X-ray tube. This is a picture of one of the first Coolidge hot cathode X-ray tubes marketed by GE. Before 1913, gas-filled Crookes tubes were used to produce X-rays. They were temperamental and produced a slow trickle of radiation. Exposure times of 1/2 hour or more were not uncommon. While modern X-ray tubes are heavier and somewhat more complex, they are not significantly different from the Coolidge hot cathode tube. Probably the biggest difference is that most medical X-ray tubes today have a rotating anode which allows for very high MA and short time exposures. Currently, stationary anode X-ray tubes are relegated to low power applications such as dental radiography. I will cover the innovation of the rotating anode in a separate presentation. To begin, let's start by naming the various components of the X-ray tube. First, we have the cathode or filament. This is a thin tungsten wire shaped in a coil. In the X-ray tube, this is the source of electrons that are used to produce X-rays. Surrounding the cathode is a metal cup. This is called the focusing cup. This unit will focus the electron stream onto the surface of the target, creating the focal spot. Opposite the cathode is a positively charged anode. A high voltage positive charge on the anode attracts and accelerates the electrons from the cathode across the gap between the cathode and anode. This part is called the target. The point where the electron stream is decelerated by the target is called the focal spot, and the electron produces a large amount of heat. A small tungsten button is embedded in the end of the anode to prevent melting or pitting of the anode surface. The anode and cathode assemblies are contained and supported within a glass envelope. Glass is rigid and holds the anode and cathode assemblies in strict alignment, and electrically insulates the cathode and anode from each other. Additionally, the glass envelope maintains a vacuum that prevents the cathode from burning. For something to burn, it requires oxygen. An aluminum shell lined with lead surrounds the tube, and this is called the tube housing. X-rays cannot be redirected once produced, so a lead covering is required to stop the non-useful off-axis radiation, called stem radiation. A 1 or 2 inch hole is cut in the housing and blocked with plastic. This is where the X-rays are allowed to escape the housing. This is the tube port. The collimator is bolted onto the port to further shape the beam to meet our needs. So let's take a moment and quickly review the tube parts. First, we have the cathode or filament, our source of electrons. Surrounding the cathode is the focusing cup. This will focus the electron stream onto the target. To the left of the cathode is the anode. It has a positive charge and attracts the electrons and conducts heat out of the X-ray tube. If the target were not there, the electron stream would melt a hole in the anode. The target can withstand the high heat of X-ray production and contains the focal spot. A glass envelope rigidly supports the anode and cathode assemblies, maintains a vacuum, and electrically insulates the anode from cathode. The vacuum is important, for without it, the cathode would burn the first time it was heated. The tube housing contains cooling oil to conduct heat from the tube to the surrounding air. It protects the fragile X-ray tube from damage and traps most of the X-rays the tube produces, only allowing a small fraction to escape the tube port. Once created, X-rays cannot be directed or redirected, so most are absorbed by the housing. A small portion can escape via a small plastic window called the tube port. The collimator is bolted onto the port to further confine and shape the beam. It is important to know what the various parts of the X-ray tube are made from and why the material is used. The cathode is a thin tungsten wire. Tungsten is expensive and difficult to work, so it is used for small parts that will be subjected to high heat. Tungsten has a very high melting point. Molybdenum has a high melting point, but not as high as tungsten. It is not as expensive and is used where components are subjected to lower temperatures. The anode is made of copper. Copper is inexpensive and an excellent conductor of heat and electricity. You may have seen cookware with copper bottoms purported to heat quickly and evenly. The anode is a large bar of copper able to store and move heat from the interior of the tube to the cooling oil that surrounds it. Again, the target is made of tungsten. The target is where electrons have their kinetic energy converted into heat and X-rays. About 98% of the energy directed to the target is converted into heat, and the remaining 2% to X-rays. If the target were not there, the electron stream would melt a hole in the face of the anode. The tube envelope is made from a special heat-resistant glass called Pyrex. This glass can stay rigid at high temperatures and resist the flow of electrons through its surface. The only path available to the electrons is to flow across the gap between the cathode and the anode. The housing is an aluminum shell lined with lead. Aluminum is hard and light, where lead is soft and malleable. The aluminum protects the tube glass from physical harm, and the lead protects patients from excess radiation exposure, excepting those rays needed to form an image. On the side of the housing is a small round port that is covered with plastic. This is the tube port, where the primary or useful radiation beam is allowed to escape the housing. The space between the tube glass envelope and housing is filled with an oil. This oil is an electrical insulator and a good conductor of heat, moving heat from the end to the housing of the tube. To summarize, the cathode is a source of electrons necessary for X-ray production. It is heated to white hot and the electrons boil off its surface by a process called thermionic emission. The cathode is made of tungsten because tungsten has a very high melting point. The anode has a high voltage electrical charge in the range of 40 to 100,000 volts and causes the electrons to jump the gap between the cathode and anode. Copper is used because it is inexpensive and is a good conductor of heat and electricity. To further summarize, the focusing cup directs and literally focuses the electron stream onto the center of the target, controlling the actual focal spot size. It is made from molybdenum, which is moderately heat resistant. The target is where the electron stream is decelerated and where the electrons emanate from the focal spot. It is made from tungsten and is very heat resistant to prevent pitting or melting of the anode. The target makes a small percentage of the anode because tungsten is an expensive material. The glass envelope is made of Pyrex, a glass that is treated so that it can stand high temperatures and not crack. The anode and cathode assemblies must be rigidly held in alignment, and glass is an ideal substance to perform this task. Additionally, electrons produced by the cathode must be forced to jump the gap from the cathode to the anode. This means that the supporting structure must not conduct electrons and act as an electrical insulator. Glass has this property. In addition to not conducting electricity, glass will conduct heat. Most materials that act as electrical insulators also do not conduct heat well. Glass is one of the few substances that won't conduct electricity, but will conduct heat. The inside of the X-ray tube must maintain a vacuum. If any oxygen gets inside the tube, the cathode will burn almost instantly. Finally, let's review the tube housing. The tube housing not only protects the patient from STEM radiation, it is also filled with an insulating cooling oil that cools the tube and also protects hospital staff and patients from high voltages necessary to produce X-rays. At one time in our history, electrocution of patients and radiographers was a real hazard in our profession. The housing consists of an aluminum shell which provides the fragile glass of the envelope with protection from physical damage. This shell is lined with lead which protects people exposed to the tube with protection from exposure to primary radiation. This will end my discussion of the X-ray tube. Thank you.